Hi guys, this is a quick review on elevation and depression because it is something that you should have done in junior school. So this is only here if you need it. I've separated it out from bearings so that you can just go over this stuff if you're a bit weak on this before you get into the bearing stuff. So the thing we need to know is that whenever we're talking about elevation and depression, we're always measuring from the horizontal. If we're talking about the angle of elevation, what we're doing is measuring generally from the ground, looking up at something that can't be physically measured, whether it's a building, a cliff, a mountain, something like that. So it's also used for things like the heights of trees because we use the shadows. So if you are standing at the bottom and you are looking up, then on this diagram here, your angle of depression is just here. And the angle of depression is what happens when we're standing at the top of something and we're looking down. Now again, it's measured from the horizontal, so even though there isn't actually a horizontal to measure, when you're using a clinometer, which is the object that they use to do this, it measures from the horizontal, and so it measures this angle down here. But hopefully you can look at that and say, well, hang on a minute, I have parallel lines, which means I've got this alternate set of angles here. As soon as we know we have an alternate set of angles, then we know that that angle there is also this angle here. So even though it's measuring an angle of depression and they're talking about the top, the angle of depression ends up being the angle of elevation. They're going to be exactly the same angle whether you were standing at the top of a building and looking down or you were standing on the ground and looking up. So that makes things a lot simpler. So a couple of examples. There's no diagrams on these. Occasionally in the HSC they'll give you a diagram, but you have to know how to draw the diagram as well. So there's a couple of practice ones here. So the angle of elevation to the top of a building 50 meters away is 30 degrees. Find the height of the building. So the first thing you want to do is draw yourself a diagram. Don't try and do these without it, because how do you know whether the unknown is on the top or the bottom? Am I multiplying? Am I dividing? Draw the diagram. It won't take you long. Okay. So we're looking at a building, and that means we're standing on the ground. So we get our right angle triangle. The height of the building is the one that we're trying to find. So we want to find this side here, the height of the building. My right angle is just here, and they're telling me that the building is 50 meters away. So what that means is if the person is standing just here, then the base of the building is 50 meters. So that's this side here. And we know that the angle of elevation, so standing at that point looking up, is 30 degrees. So the 30 fits in here. So looking at our trig ratios, we've got x and 50, they're opposite and adjacent. So we are talking about tan, which in angle of elevation and depression questions is quite common because it's very difficult to measure the hypotenuse. It generally talks about this. It's not impossible. If they're talking about wires or ramps going up to something, they'll talk about the hypotenuse, but quite often you'll end up with a tan. So we know that tan of 30 is equal to x over 50. So hopefully by now you're very easily going to be able to tell me, well, that means that x equals 50 tan 30. And once we pop that into the calculator, we get our answer 28.86751346. Now this question hasn't told us how accurate they want it to be, so you need to judge the reasonableness of your answer. We're being given measurements in meters. We really can't measure to 8 decimal places, so I'm going to round this off to 2 decimal places because that'll get me to centimeters. So there's the height of the building. Alright, so I want you to have a go at the next one yourself. So pause the recording and have a go. Draw your picture, fill in the details, figure out which ratio it is, and then solve it. And once you think you've got it, come back and check whether or not you got it right. Alright, so we are standing at the top of a cliff 115 meters high, and a boat can be seen at an angle of depression of 25 degrees, and we want to find the distance from the base of the cliff to the boat. So They're all triangles, okay? Start off with your triangle. So right angle triangle, and if you need it, then you can draw your little thing to show that this is your cliff. So the little person is standing up here. Okay? The angle of depression. So that means we're measuring from this horizontal here, and they've told us that the angle of depression is 25 degrees. We know that the cliff is 115 meters high, and we want to know how far away the boat is from the base. So we're trying to measure this distance here because that's our boat just there. Now the problem that we have is our 25-degree angle is outside our triangle, so we can't use it there. But remembering, hopefully, that because we get these parallel lines, the horizontal, the ground is horizontal, or in this case the water is horizontal, it's measured from the horizontal at the top, so alternate angles means that this angle here is 25 degrees. You don't have to go through a proof to show that they're alternate angles, that's just an accepted thing, they're both horizontal, so you don't have to prove that. So we're dealing with opposite and adjacent, so again we've got a tan. So it is tan of 25 degrees is equal to the opposite, so 115 over the adjacent x. Hopefully by now we can skip the extra step and go straight to x equals 115 all over tan of 25. So when we type that in, and remember I want the whole calculator answer, don't round off until you've written the whole thing down, because if you've screwed up somewhere you don't want to miss out on the marks, something silly. So it's 246.6182959, which again we're talking meters. We're going to round off. I'm going to round this one off to the nearest meter because we're talking about a fair distance. Those extra 61 centimeters, not so important. So we're going to round that off to 247 meters. And that's how you do angles of elevation and depression.